Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hi students, so again welcome back into complex form of Fourier series, and this time we are gonna cover a numerical where f of x is given in multiple ranges. So it means we won't be having a single value of f of x, we'll be having the multiple values of f of x depending on the ranges. So let's see how to find out the complex form of Fourier series for such f of x. So here we have to find out the complex form of Fourier series for f of x, where a value of f of x is 0 in the range 0 to L and the value of f of x is a in the interval L to 2L. Now guys, how to get that value? So let me tell you that if I want to find out the complex form of Fourier series, the basic formula of complex form of Fourier series is gonna remain same. So I'm sure that you have watched my previous videos where I've covered the different formulae which are required to find out the complex form of Fourier series. So guys, let's use that formula over here and let's find out the complex form of Fourier series for this f of x. So guys, this is the formula to find out the complex form of Fourier series for f of x. So I'll be calling this as equation number 1. Now guys, here Cn is the unknown. So we have to find out the value of Cn and then put that value in equation number 1 to get the complex form of Fourier series. Now the question is, what is the formula of Cn? So here I'll write it down. So Cn is now guys, here f of x is given in two parts, that is 0 to L and L to 2L. So what we'll do is we will also divide this given range into two parts. So I'll make first range as 0 to L and I'll make second range or second interval as L to 2L, and we will take respective value of f of x from here. So now guys, in the first range 0 to L, the value of f of x is 0. So it means if we put 0 here, we'll get 0 into this, that is 0. So I'll be writing 0 tx. Plus the second range is L to 2L. And in this range, the value of f of x is a. So I'll be getting a into this. So a into e to the power now guys, since we are getting this first integration as 0, we'll be evaluating the second one. So in the second one, a is a constant, so I'll be taking it outside. So here we will get a upon 2L outside. And in the integration, we have e to the power negative and pi x by L, and we will now integrate with respect to x. So here I'll get and the limit is from L to 2L. So guys, I'm sure that you have revised the integration as well, because you have to find out the integration and then only you can proceed further and get the answer. Now here this value is a constant because it does not have any x, so I'll be taking it outside. So guys, before taking it, I can cancel this L with L, and here we will get negative a upon, so minus n has come outside, and we'll get 2I n pi. And now in this remaining function, I'll be putting 2L and then L in x. So if I put 2L, we will get I n pi 2L upon L. Obviously negative sign is there, so L and L cancel, so we will get e to the power negative 2I n pi. Then middle sign negative, let's put the lower limit. If I put L, L and L cancel, we'll get e to the power negative I n pi. Now guys, we can also evaluate these two terms. So we have used the formulae, that is I can easily figure out that these two given terms are nothing but the exponential form of complex number. So we have a formula for that, so I'll be converting it into the polar form. So guys, we have a formula that e to the power I theta is cos theta plus I sin theta. So I'll be using that formula over here. So we'll get negative a upon 2i n pi, and in the bracket this term will become cos of 2n pi minus I sin 2n pi minus, so negative sign is there, we have one more term, so I'll write that term in bracket, and this will become cos of n pi minus I sin n pi. Now guys, we know the values of this, so if you don't know, you have to go back in the Fourier series where I've covered most important results and formulae, and I've shown you how do we get value of this. So value of cos of 2n pi is 1, so here I'll write down minus a upon 2i n pi. Now this is 1. Sine of 2n pi is 0. Then cos of 2n pi is negative 1 raised to n. So minus n is as it is. Here I'll write down it is as minus 1 raised to n. And guys, then sine of n pi is 0. So this is what the value of Cn. Now guys, we will be substituting this value of Cn in equation number 1. But hold on, because if you put this value of Cn over here, and if you are observing carefully, we are gonna put the value of n from negative infinity to positive infinity. Now guys, here in Cn, let's say if I put all values from negative infinity to positive infinity, so in that range we get one value which is called as 0. So when n will become 0, what will happen, that this Cn, here in the denominator we have n, and this will become 0. And we know that in mathematics, whenever denominator becomes 0, our answer becomes infinity. So it means the value of Cn will be infinite at n equal to 0. And since guys this is a summation, so summation is nothing but the addition. So in the summation, let's say, or in the addition, let's say one term is becoming infinity and other terms are finite, still the addition will be infinite. So we should not get an answer, so we should get the finite answer. So it means that the value of Cn at n equal to 0 is not acceptable. So I can say that this value is acceptable for all other values of n except at n equal to 0. So here in the bracket I'll say except at n equal to 0. So it clearly indicates that we are accepting this value of Cn for all values of n except n equal to 0. So it means at n equal to 0 we have to find out the value of Cn, and that value must be finite. Now the question is how to find out that value. So guys, I'm sure that you're watching all my videos. So in the Fourier series also we got same type of case. So there what we did is we substituted that n equal to 0 again back in the original formula. So this is the formula of Cn. So there I'll be putting the value of n. So either I'll put here, or here I started the Cn. So here I'll be putting n equal to 0, and we will again resolve it to get the value of Cn at n equal to 0. So I'll say put n equals to 0 in Cn. So that will become C0 equal to, here we have n only in one term, so e to the power 0 is 1. So guys, here we will just get f of x dx, and remaining terms are as it is. So now guys, value of f of x in 0, 2l, here it is given. So two values are there. So first value will not take because it's 0. So I'll be directly taking second value, that is which is valid for L to 2l. So guys, this range will become 1 upon 2l integral from L to 2l, and that time the f of x is a as given in the question. So a is a constant, I'll take it outside, so that will become a upon 2l, and integration of 1 is x, and limit is from L to 2l. Now if I put upper and lower limit, that will become 2l minus L is L, and guys that L will cancel with this L, and we will get answer as a upon 2. So it means the value of C0 is a by 2. So guys, we got value of Cn at n equal to 0. Now we have to find out the value of Cn this value of Cn for all positive. Here I'll show you that our n is varying from negative infinity to infinity, hence we have to find out that value of Cn for all positive n's and then for all negative n's. So here how we'll do is, guys, there is one more thing to notice, that here whenever this power n, you can observe it carefully, that whenever this power n is even, that time this minus 1 raised to even will become positive 1, and that 1 minus 1 will become 0. It means whenever n is even, we are getting value of Cn as 0. So guys, what we'll do is, instead of dividing that Cn as positive for positive values of n and negative values of n, we'll divide it into two parts, that is even values of n and odd values of n. So let's consider even values of n and then odd values of n, and let's see what are the different values we are getting, and then we will substitute all those values here in this Cn. So let's start. So here I'll say when n is equal to, now 0 I have taken already, so next even values starts from 2, so plus or minus 2 or plus or minus 4 or plus or minus 6 and so on. So till positive infinity, and here till negative infinity. So let's see what we get. So guys, let's assume the first value as 2 or second as minus 2. Let's see what we get. So whenever this n is 2, here we will get C2. So I'll write down one steps, C2, and here for finding C2 we have to put minus 1 raised to 2, but guys, minus 1 raised to 2 is 1 and 1 minus 1 0, it means we will get value of C2 as 0. Similarly, if we'll try to find out C of minus 2, so here we will get minus 1 raised to minus 2, and guys, that is also equal to 1. Now how? Let me show you that minus 1 raised to minus 2 is 1 upon minus 1 square, and that becomes 1 upon 1 is 1. Now guys, I'm showing this thing to you purposely because I found many students who get confused that why minus 1 raised to minus 2 is 1. So this is what the reason is, and I've done it by using the laws of indices. So guys, again that is 1, so 1 minus 1 0, it means for n equal to minus 2 we are again getting 0. So it means for all even values we'll get 0. So for C4 we'll get 0, then for C of minus 4 we will get that answer as 0, and we'll get all further values as 0. It means for all even values of n we are getting Cn as 0. Now let's move to the odd values of n. So here I'll say when n is plus or minus 1, 3, 5 and so on. So guys, I'm taking all odd values and we are going to start with the first value, that is positive 1. So when n is positive 1, let's see what we get. So guys, this is what the value of Cn. So here I'll say C1 is equal to minus a upon 2I pi, since the value of n is 1. So guys, here we have n and that is 1. Next here minus 1 raised to 1 is minus 1, so that will become plus 1. So 1 plus 1 is 2. So guys, here we will get straightforward 2. Now 2 and 2 we can cancel and we will get value as minus a upon I pi. Now let's find out value for C of minus 1. So if n is negative 1, what will happen? Here we'll put n as negative 1 and negative will become positive, and we will get a upon 2I pi. Now let's see what we get in bracket. So here we'll get minus 1 raised to minus 1. Guys, that is again minus 1 using the same relationship. So minus 1 and this minus is plus. So 1 plus 1 is 2. So here I'll say it is 2, 2 and 2 cancelled, and guys, we will get a upon I pi. So we got two values. Now let's find it out for C3, and let's assume what could be the C of minus 3 and the further values. So C3 is equal to, so n is 3 now, so this will become 3 2s are 6, so minus a upon 6I pi. Here minus 1 cube is minus 1, minus minus plus, so here again I'll get 2, so that answer is negative a upon 3I pi. So by cancelling 2 and this 6. Next let's find out C of minus 3. So when it is negative 3, I'll be getting minus 3 into 2, that is minus 6, minus minus cancelled. I'll be getting a upon 6I pi. And guys, here if n is minus 3, again we will get 2 by using the same relationship. So here we have 2. So it means the answer is a upon 3I pi. Now guys, observe the pattern. When we want C1, here in the denominator we are getting 1I pi. C3 we are getting 3I pi. For 5 we will get 5I pi, and so on. And similarly for positive values we are getting negative answers, and for negative values we are getting positive answers. So same things will happen with C5, C minus. So here if I ask you what will be the value of C5, come on, let's see who is answering correctly. So value of C5 is negative a upon 5I pi. Similarly, the value of C of negative 5 will be a upon 5I pi. So guys, we will get so many values. Now we got the values for n equal to even, or n equal to odd, and n equal to 0. It means we got all values of Cn for all different values of n. Now let's put all these values together in the equation number 1. So here I'll say from equation number 1. Now guys, before substituting these values in equation number 1, you have to be smarter, because if you see this equation number 1, then it says that n is varying from negative infinity to infinity. Now we can't take n from negative infinity to infinity, because if we do it for next 1 year also, then also the sum will not end up. So we will be taking few values of n. So what I'll do is I'll take one value of n as 0, then I'll take two neighboring values, that is 1n minus 1, then 2n minus 2, and then we'll put dot 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 dot. So it means the series is continuing to the negative infinity side as well as positive infinity side. So how we'll do that? So let's take different values of n. So what I'll do is, guys, for writing purpose, I'll be starting from negative side, that is, let's say negative 3. So if n is negative 3, here I'll get C of minus 3, and here I'll get e to the power minus 3 pi x upon L. So guys, n is minus 3. So this will become negative 3, this will become negative 3. So value of C of minus 3, we already got it. I'll put that value over there. So here I'll say that f of x is equal to, so I'll be first putting dots because we are coming from negative infinity side, then plus, now we are putting n equal to minus 3. So here we'll get C of minus 3, and C of minus 3 is a upon 3I pi. Next, here we will get e to the power negative 3I pi x upon L. So guys, after negative 3, let's come ahead, let's put value of n as negative 2. From negative 3, then we get value of negative 2. But for negative 2, we got the value of Cn as 0. Here I'll show you that for C equal to minus 2, we got 0. So we will not write that term. Next, move ahead, we have C of minus 1. Now, for minus 1, we got this value. So I'll be putting this value. So here we will get C of minus 1 and e to the power negative I pi x upon L. So we'll get plus a upon I pi e to the power negative I pi x upon L. So after this, the next value of n is 0. So guys, we got value for minus 3, then minus 2, minus 1, now 0. So for n equal to 0, we should have the value of C0 or C0. So guys, here you can see the value of C0, which is a upon 2. So in this result, If we put n equal to 0, here we'll get c naught, and here n will be 0, so e to the power 0 is 1. So we'll not write that term, we'll just write the term of c naught. So guys, c naught is a upon 2. Now next, let's take value of n as 1. So I'm coming in series, guys. So n is 1, so here I'll get c1, and here I'll get e to the power I pi x upon n. Now what is the value of c1? So I'll write down that value, it is same but negative sign. So minus a upon I pi into e to the power I pi x upon L. Next, after 1, here we will substitute value of n as 2. So if it is 2, we will get c2. And guys, let me tell you that value of c2 we got as 0. So we'll ignore that. Next value of n is 3. So c3, and here I'll get I3 pi x upon L. So value of c3 we have. It is similar to this with negative sign. So negative a upon 3I pi into e to the power 3I pi x upon L minus dot dot dot. So guys, what I did here is I just took the values between negative 3 to 3, and then I put dot dot on both sides. So this is what the complex form of Fourier series for given function. So guys, we can still minimize it by taking few terms common. So for example, a upon 2 is alone, so I'll be taking a upon 2 as it is. Now let's see this second term and the fourth term. In these two terms I can take a upon I pi common. So here let's say a upon I pi common, and in the bracket from here we will get e to the power minus I pi x upon L, and from here minus e to the power I pi x upon L. Similarly, from first and fifth term we can take plus a upon 3I pi common. In the bracket from here we will get e to the power negative 3I pi x upon L minus e to the power 3I pi x upon L, and plus dot 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 dot, because it's an infinite series. Now guys, here we can use the formula. So what I'll do is a upon 2, I'll keep it as it is. Now if I want to apply the formula, so here what we have to do is we have to bring 2i in the denominator, and we should get this positive power first and then negative power, because that becomes the formula of sine. So for that I'll multiply and divide it by 2. So, and I'll take negative sign outside. So if I take negative sign outside, I'll get negative a, then I'm multiplying by 2, so 2 will be here and pi will be there. So I'm multiplying by 2, I'm dividing by 2, so here I'll get 2i, and I'll take that 2i inside. So here I'll get e to the power I pi x upon L minus e to the power minus I pi x upon L whole upon 2i. So guys, I've taken negative sign outside, and that is why this term will become positive and this term will become negative. Now here also I'll do the same thing. So for that I'll take negative sign outside, I'll multiply and divide by 2. So this will become 2a upon 3 pi. So this is multiplication by 2, and when I'll divide by 2 I'll get 2i term. I'll shift that 2i in the bracket. So here we will get in bracket e to the power 3I pi x upon L minus e to the power negative 3I pi x upon L whole upon 2i plus dot dot dot. And guys, now it's the last step. We will put the formula for this. So the value of f of x is a by 2 as it is, then here minus 2a by pi as it is, and this is the formula of sine. By Euler's formula, it is sine of pi x upon L. Similarly, by Euler's formula, this will be 3 pi x by L. So we'll get minus 2a upon 3 pi sine of 3 pi x upon L. So minus dot dot dot. And guys, here we got the complex form of Fourier series for given function. So I'm sure that you understood how I used the different values of n and I got the complex form of Fourier series. So guys, keep watching the videos. and also don't forget to share it with your friends because they can also get benefited through these videos. Thank you very much.